Welcome to the Introduction to XenApp 6.5 video series. Let's get started. This video will give an overview of what XenApp is and the different components in the XenApp architecture. Knowing the different components of XenApp is helpful for anyone deploying XenApp, especially for anyone who is approaching XenApp for the first time. Citrix XenApp is an on-demand application delivery solution that enables any Windows application to be virtualized, centralized in the data center, and instantly delivered as a service to users anywhere on any device. Proper farm design is the most important aspect to having a well-performing, scalable farm. So let's discover the different server roles in a XenApp farm. The license server is responsible for storing and managing Citrix licenses. The web interface server hosts the web pages that users connect to access their applications. The data collector maintains information about the XenApp servers. The XML server queries the server farm for a list of published applications that the user has permission to access. The database server, or data store, is the database that contains information about published applications, users, printers, and servers. The XenApp worker servers, or application servers, are the servers that host the applications. Storefront authenticates users to the XenApp farm, and Access Gateway provides secure access to Citrix XenApp applications and desktops. Citrix Receiver is the universal software client that provides secure, high-definition, high-performance delivery of applications. It is common practice to group one or more of these infrastructure services into small farms. In large deployments, each service runs on one or more dedicated servers for scalability and redundancy. The slides that follow categorize the XenApp deployment model into groups based on the number of users and servers hosting the applications and desktops. While farm size, as determined by the number of servers, can indicate the general category your farm is in, another important factor to consider is the number of user connections. In a small farm with less than 100 users, you might need less than 5 XenApp worker servers. For small environments, all roles can be placed on a single server. As the number of users increase, it's important to know where the bottlenecks are occurring. Once a bottleneck is identified, you need to move the affected services to their own server. This training series will focus on a small XenApp farm deployment. As bottlenecks happen and CPU resources become scarce, more application and XenApp servers will need to be added. As the user count increases, the combined overhead of server resolutions and application enumerations, SQL database resource usage, and HTTP requests will require infrastructure services to be placed on dedicated servers. In enterprise-class deployments with more than 5,000 users, disaster recovery and failover capabilities become critically important. Each infrastructure service will be dedicated to one or more servers. Supported operating systems for XenApp 6.5 are Windows Server 2008 R2 and 2008 R2 Service Pack 1. Most servers running on supported operating systems meet the hardware requirements for XenApp. However, additional research may be needed to determine if current hardware meets the requirements. The number of users a XenApp server can support depends on several factors, including the server's hardware specs, the applications deployed, and their CPU and memory requirements, and the amount of user data being processed by the applications. Good farm design is important to ensure a high-quality experience for users. There are some good XenApp sizing guides out on the internet if you search for them. These guides will help you determine what types of hardware you need to procure in terms of memory, CPU, and disk storage. For example, HP makes available a sizer for Citrix XenApp for enterprise and SMB deployments. Also, please keep in mind that the hardware requirements for a farm built on top of physical servers will be slightly different than a farm built on virtual machine. For clarification and official documentation, please reference docs.citrix.com. This is Citrix's electronic documentation system. To access support articles, support forums, and the knowledge base, please reference support.citrix.com. On this site, you will find CTX articles such as CTX 13102, which is a XenApp sizing guide to help you estimate server hardware and software resources when building your farm. Next, we will talk about the different XenApp components individually and the roles they play, starting with the license server and worker servers. Let's talk about the license server and worker servers. This video provides an overview of the Citrix license server and the application worker servers. The license server and worker servers play important roles in the XenApp farm. The Citrix license server can be either a shared or dedicated server that runs the Citrix license server software. Its sole function is storing and managing licenses for Citrix products such as XenApp. Citrix products, such as XenApp, request licenses from the license server when a user attempts to connect to XenApp. The XenApp server sends a request to check out a license from the license server on behalf of the user, and when the license is successfully checked out, the user can run the application from XenApp. The Citrix license server can be installed on the same server as the XenApp server for small deployments, but is recommended to install the license server on a dedicated server for medium to large XenApp farms. The license server is also available as a downloadable virtual machine. Citrix XenApp goes through a three-step process to check out licenses. At startup, the XenApp server checks out a startup license from the license server. When a user connects to the XenApp server, XenApp requests a license from the license server. If product servers lose communication with the license server, the users and products are protected by a grace period of 30 days. That allows the product servers to continue operations as if they were still in communication with the license server. Worker servers run the applications that you publish to your users. Multiple XenApp worker servers in the same farm can be added to a worker group, which can be managed as a single unit. When using worker groups, consider the following. A farm server can belong to multiple worker groups. A worker group can include any number of XenApp servers or not at all. And only servers that belong to the same XenApp farm are included in a worker group. When publishing an application, you can use worker groups to specify the servers hosting the application. And to increase capacity for the application, you can add more servers to the worker group rather than modify the application properties. Worker groups are collections of XenApp servers residing in the same farm that are managed as a single unit. Using worker groups, you can streamline application publishing to multiple farm servers by adding more servers to the group, load balance access to published resources. You can use the worker group filter in the Citrix Policy Manager to apply policy settings, and assign load evaluators to multiple farm servers. Next, we will talk about the web interface, data collector, and XML server. Let's talk about the web interface, data collector, XML server. This video provides an overview of the XenApp web interface, data collector, and XML server. The web interface, data collector, and XML server play important roles in the XenApp farm. The web interface is installed on Windows Server using IIS to host applications. Users access their applications through the web interface. There are two web interface types: websites, which provide users with a website they can log on to and launch applications using a browser, and services sites, which interact directly with Citrix Receiver to deliver applications. Users authenticate to the web interface through a web browser, which passes the information to the XML server, who acts as a broker between the web interface server and the other servers in the farm. The XML server returns the list of resources the user has access to, and then these are displayed in the web browser. The user clicks and launches the application, content resource, or desktop. The user must have a Citrix client installed to run the application, resource, or desktop, and this can be installed by accessing the web interface. The data collector manages all of the dynamic information in the XenApp farm. Dynamic information consists of items that change often, such as connected sessions, disconnected sessions, and server loads. It also contains session information for the entire farm, which is replicated to other backup data collectors. The other main responsibility of the data collector is to find the least busy server and tell the client to launch the application from it. The data collector is installed automatically on the first server in the XenApp farm. A zone is a grouping of XenApp servers that communicate with a common data collector. In large farms with multiple zones, each zone has a server designated as its data collector. The data collector maintains all load and session information for the servers in its zone. All farms have at least one, and the fewest number of zones is the best way to implement them. Multiple zones are necessary only in large farms that span across wide area network. The XML server is the broker between the web interface and XenApp servers. It communicates published application information that the user has access to the web interface server. It responds with the address of the application server when a user launches an app, and it should be configured on the same server as the data collector. Next, we will talk about the XenApp database, also referred to as the data store. Let's talk about the data store. This video provides an overview of the XenApp database or data store. The data store stores important information regarding the XenApp farm. The data store keeps track of farm information, such as configuration information about applications, users, printers, and servers. Each farm has a single data store. Supported databases include SQL Server 2012, SQL Server 2012 R2 Service Pack 1, and SQL Server 2008 R2. The server hosting the Microsoft SQL Server database should meet the following minimum requirements, which is approximately 100 megabytes of disk space for every 250 servers and 50 published applications in the farm. Set the temp database to automatically grow on a partition with at least 1 gig of free disk space. Citrix recommends 4 gigabytes if the farm is large and includes multiple print drivers. The default installation settings are sufficient for most XenApp data store needs, and you need to use Windows authentication. Each XenApp farm requires a dedicated database. However, multiple databases can be running on a single server running Microsoft SQL Server. Make sure you don't share the database with any other applications. Consider these factors before deciding which database to use: the number of servers you currently plan to have in the farm and whether or not you plan to expand that number. Microsoft SQL Server is suitable for any size environment and is recommended for all environments. SQL Server Express is suitable only for small environments. This chart tells you which type of SQL Server you will need, and the size of the farm can be determined by the number of users you expect to have logging in and launching applications. For example, for less than 150 users, you can use SQL Express or SQL Server. For anything larger, you will want to use the regular SQL Server product for its scalability. In previous versions of XenApp, when you joined a new server to a farm, a significant amount of time was spent waiting for the Citrix Independent Management Architecture service to start and come online, because each XenApp server had to download all of the farm data to its localhost cache. To avoid this, you would configure SQL Data Store replication at each remote site and allow member servers to use the local SQL instance, instead of utilizing the WAN. However, with XenApp 6.5 and its new Session Host mode, data store replication is no longer needed. Session Host mode allows XenApp servers to just host user sessions and not perform controller or collector tasks. This enhancement, in addition to architectural changes in XenApp 6.5, make data store replication unnecessary. In addition, future versions of Microsoft SQL may not support the replication model that XenApp supports. It's important to note that when a data store goes offline, each XenApp server stores a subset of the data in its local host cache and will continue to work using the local cache without modifying the farm. Next, we will be taking a look at the Citrix Receiver client that is deployed on the client devices. Let's talk about the Citrix clients. This video provides an overview of the clients used to connect to XenApp resources. Various clients come into play, so it's important to know the functions of each. Citrix Receiver is a universal software client that provides secure, high-performance delivery of applications and virtual desktops. It provides simple, self-service access to desktops and applications, a high-definition user experience on any network or device, instant updates to users with IT control and visibility, and easy management of enterprise applications, data, desktop, and SaaS apps through a secure, centralized deployment to any user device. The offline plugin runs as a service on the user device to invoke applications the user selects and applications enumerated by Citrix Receiver or the web interface site. The online plugin supports XenApp and XenDesktop connection. Using Citrix XenApp with the web interface, you can integrate published resources directly with users' desktops. You centrally administer and configure the plugin in the XenApp App Center console with a web interface services site. The online plugin allows XenApp users to access all of their published applications and resources from their familiar desktop environment, whether it's Windows, Mac, mobile devices, or thin clients. The web plugin is a smaller, more limited plugin that doesn't require administrative rights to install on the user's client device. if you want users to access published resources and virtual desktops from within a familiar browser environment, you would use the web plugin. The web plugin does not require user configuration and does not have a user interface. In fact, you can install the web plugin simply by connecting to a XenApp web interface through an internet browser. Next, we will be taking a look at the Access Gateway, which is the component used to secure communications to the XenApp farm over HTTPS. Let's talk about the Access Gateway. This video gives an overview of the Citrix Access Gateway. The Access Gateway is important for securing communications with the XenApp farm. The Access Gateway is important when you want to provide secure access to XenApp and the applications. Secure ICA is encryption for the ICA protocol and is integrated into XenApp by default. Access Gateway essentially provides secure communication using HTTPS or SSL TLS protocols for communications with clients, but it can also do the following. The Access Gateway can use cryptographic modules that are FIPS 140 validated. It can use SSL version 3 or TLS version 1 to encrypt communication between the clients and the XenApp farm. You can use smart cards with XenApp, supported XenApp plugins, the web interface, and single sign-on to provide secure access to applications and data. XenApp can extend the use of Kerberos and use tokens for authentication. Access Gateway can be used with RSA, Secure ID, and SafeWord by Aladdin. Access Gateway is a term often used in conjunction with network security. There are two ways to provide secure communications to the XenApp farm. The first can be done by installing the Secure Gateway software onto an IIS server. This is included with the XenApp installation media. The second, more popular, more scalable method is to install the Access Gateway as either a hardware appliance or virtual machine. The Access Gateway provides SSL terminated connections for the clients connecting to the XenApp farm so that all communications are secured. The Access Gateway is typically installed in a single hop configuration, that is, in a DMZ network that separates the secure communication from the back-end XenApp farm, which you can see in the example diagram here. If you are using the Secure Gateway instead of the Access Gateway appliance, you would substitute a Microsoft Windows server here and install the Secure Gateway software on top of it. Keep in mind the Secure Gateway software is not very scalable and is not the recommended implementation. The Access Gateway can be placed into a double hop configuration, that is, where two DMZ networks separate the secure communication from the back-end XenApp farm, which you can see in the example diagram here. Next, we will be taking a look at the new component to XenApp called Storefront. Let's talk about a new component called Citrix Storefront. This video gives an overview of the Citrix Storefront. It provides authentication and resource delivery services for Citrix Receiver and is a new component, which is part of the Cloud Gateway product, but let's look at how it is used. XenApp is expanding with the Citrix portfolio. With Citrix Storefront, it is new to XenApp. It is an interface that authenticates users to not only XenApp, but XenDesktop by enumerating and aggregating virtual desktops and applications into a single interface that users access through the Citrix Receiver. The Storefront database records details of user application subscriptions, which enables synchronization of those applications across all of their devices. Citrix Cloud Gateway is the industry's first unified service broker that aggregates, controls, and securely delivers Windows, web, software as a service applications, iOS and Android applications, integrated share file-based data, and virtual desktops to any device anywhere. Cloud Gateway gives users an intuitive single point of access and self-service to all of their business applications on any device, anywhere. It also provides IT with a comprehensive single point of aggregation and control for all applications and users. The Cloud Gateway contains several components. The App Controller, which is a software solution that enables you to aggregate, control, and deliver web, mobile, SaaS apps, and share file documents to any device. App Controller empowers users with a single point of access and self-service for the apps from any device. It also provides you with contextual controls and automated provisioning of user accounts for supported applications. Users can connect with self-service to access their applications and documents. Access Gateway is a secure application access solution that provides granular policy and action controls to secure applications and data. Storefront exists with existing XenApp and XenDesktop deployments, enabling the delivery of applications and desktops to any device through a unified self-service storefront. And of course, Citrix Receiver is the client software installed on the user device that connects to Storefront to access the desktop's applications and data. Storefront and Cloud Gateway are advanced topics, and they are new to XenApp. And because we are focusing on an introductory course for XenApp 6.5, they are presented here, but we won't go into them in much detail any further. When both desktops and applications are available from a site, Receiver for Web displays separate desktop and application views. You can install Receiver for HTML5 on your Storefront server to enable users with compatible browsers to access applications using Receiver for HTML5. The initial configuration process has been simplified using a wizard, and if you are using the Access Gateway, you can also use Smart Access to control user access to XenDesktop and XenApp resources using Access Gateway policies. In the next section, we will talk about management tools for XenApp.
Let's talk about management tools for XenApp. This video provides an introduction to the different management tools for XenApp. Knowing the right management tools is essential for anyone deploying XenApp. There are several tools available to manage the Citrix XenApp farm, most of them available on the XenApp installation media. Citrix App Center is the new name for the Delivery Services Console, or Access Management Console, in XenApp 6.5. It is a tool that snaps into the Microsoft Management Console and runs on the XenApp server or a management server. App Center allows you to perform a number of management functions such as publish resources or applications to your users, monitor servers and server farms, configure application access through the client, set up policies and printers, manage load balancing, diagnose problems, view and install hotfixes, and track administrative changes. When you publish an application, configuration information for the application is stored in the data store for the server farm. The configuration information includes what type of files are associated with the application, users who can connect, importance level for preferential load balancing, and client-side session properties that include window size, number of colors, encryption, audio settings, and when delivered to users, published applications appear very similar to applications running locally on the user device. In App Center, you provide users access to information by publishing the resources. When you publish applications, you make them available to users, and the applications appear to be running locally on their client device. This is the most common method of making applications available to users. Streamed applications use application profiles stored on a file server in the App Hub. Users access the profile and virtualize the applications on their client desktops. This requires some additional preparation. Web pages, documents, media files, spreadsheets, and URLs are all forms of content that can be published to users. You can also make available the server desktop to users, but you should lock down the server from sensitive areas if you choose to do this. The Web Interface Management Console is a Microsoft Management Console, a snap-in that enables you to create and configure XenApp Web and XenApp Services sites hosted on a Microsoft Information Services server. With a XenApp website, you can provide users with a website to which they can log on to using a web browser. Once authenticated, users can access applications and resources using the web browser and a Citrix client. With a XenApp Services site, you can use the Citrix Online plugin to integrate applications and resources with users' desktops. Users access applications, virtual desktops, and online content by clicking icons on their desktop or start menu. The License Administration Console lets you manage and monitor your Citrix licenses through a web browser. Citrix EdgeSite is a performance, availability, and alert management solution for XenApp, XenDesktop, and endpoint systems. EdgeSite monitors applications, devices, sessions, license usage, and the network in real time, allowing users to quickly analyze, resolve, and proactively prevent problems. While monitoring used to be performed in App Center, it is moving away from that and is now being managed in EdgeSite. XenApp uses Microsoft Active Directory to manage permissions to the XenApp farm. Control over user access and session environments are done with policies. You can create policies for specific groups of users, devices, or connection types. You can manage policies through the Group Policy Management Console in Windows or the App Center. Policies will be covered in more detail in a later section. The Shadow taskbar allows you to monitor multiple ICA sessions from a single location. The XenApp Server Role Manager is a wizard that assists you with installing and configuring XenApp. There are third-party tools out there for managing XenApp, and we'll take a look at how to find them. PowerShell scripts for XenApp are very powerful and can be used for many purposes and will be covered in a later section. The Access Gateway console is accessed through a web browser. The Access Gateway is a secure application and desktop access solution. The appliance gives administrators granular application-level policy and action controls to secure access to applications and data while allowing users to work from anywhere on any device. Next, we will be taking a look at Citrix App Center, formerly called Delivery Services Console or Access Management Console. Let's talk about Citrix App Center. Out of the two most important XenApp management tools, App Center is one of them. You use this tool to manage the XenApp server farm and make applications available to your users. You access the Citrix XenApp console by navigating from the Start menu to Administrative Tools, Citrix, Management Consoles, and then select Citrix App Center. App Center is where you publish applications and resources to make them available to your end users. To publish an application, select the Applications folder, go to the right-hand navigation, and click on Publish Application. We're going to publish the Calculator application. Here you see the different types of content that we can publish. We can publish the server desktop, some content, or an application that's hosted on a server. We will specify the name of the executable program that we want to publish and where to find that application. We specify which server in the XenApp farm we want to run this application from. And we only want domain authenticated users to launch this application, so we will select the domain users group and finish publishing that application. Under the Views section, you can monitor servers, server farms, and sessions. If you right-click on an application and go to Properties, you can view and modify application access. Here you can look at load balancing policies and load evaluators. This is where you deploy your policies. And we'll enter a sample health monitoring policy here to use as an example. And we'll apply that policy to a worker group we've created. We can also view and manage and apply any hotfixes that were released that we need to apply to our XenApp farm. And we can view logging to see the configuration changes that were made. And it's worth mentioning that this is where you can find your worker groups and single sign-on if you wish to look into that at a later time. Next, we will take a look at the web interface management. Let's talk about the web interface manager. The next most important XenApp management tool is web interface management. You use this tool to provide a way for your users to access your published resources or applications. The Web Interface Management Console is a Microsoft Management Console snap-in that allows you to create and configure XenApp Web and XenApp Services sites hosted on a Microsoft IIS server. With a XenApp website, you can provide users with a website to which they can log on to using a web browser. Once authenticated, users can access resources and applications using a Citrix client through the web browser. With a XenApp Services site, you can use the Citrix Online plugin in conjunction with the web interface to integrate resources with users' desktops. Users access applications, virtual desktops, and online content by clicking icons on their desktop or their Start menu, or by clicking in the notification area of their computer desktop. You can determine what, if any, configuration options your users can access and modify, such as audio, display, and logon settings, and you use a services site to deliver applications and desktops directly to a client device without going through a web browser. This is useful for non-Windows devices such as Linux machines, iPhones, iPads, Android devices, and tablets. The website delivers applications and desktops to a web browser. The services site delivers applications and desktops directly to Citrix Receiver on any device, anywhere. To create a XenApp website, we launch Web Interface Management, select Create Site, and we're going to use the default IIS site for this website. At the point of authentication, we could specify the access gateway, but we're not working with the access gateway in this demo, so we'll just select at Web Interface. We then give the farm a name. We add the servers that we want to be a part of that farm, select the rest of defaults, and we now have a website for XenApp. We can test this out by opening a browser and entering localhost, and it brings up the XenApp login screen. We can test this out by logging in as administrator, and you can see all of the applications that we have published. Those applications were published in the App Center application. We'll just click on one of those and launch it to see what happens. And you see it launch, and there is our virtual application. Now, if we want to create a XenApp Services site, we click on XenApp Services Site and then Create Site. We configure the farm similar to the way we did the website. And we now have a Citrix Services site that can deliver applications to the Citrix Receiver. We can test this out by going to the Citrix website and downloading and installing the Citrix Receiver. We can launch the Citrix Receiver, add the applications. Now, if you go to the Start menu on this machine, you'll see those applications showing up in the Start menu. We can select one of those applications and it will be delivered to the Citrix Receiver. To show you how powerful this is, we can look at an iPad here. We'll launch the Citrix Receiver. And you see I have some applications that I've launched here. I can go up and switch between applications. I'm running Microsoft Office here, Microsoft Word, PowerPoint, Excel, and I can even go in and look at my Outlook email. Next, we'll take a look at the Citrix License Management Console. Let's talk about the License Management Console. This video shows you how to manage licenses for your Citrix products. You can launch the License Management Console from the Start menu. It runs in a web browser. In the dashboard, you can monitor your licenses. Under Administration, you can view system information. To add more licenses to your license server, you would select Vendor Daemon Configuration, select the file and import it, and then go back to the dashboard and check. In order to download your license files, you would navigate to mycitrix.com and log in with your credentials. Select Choose a Toolbox, Manage Licenses. Then you want to select Allocate. Select the license that you want to allocate. Click on Continue and then enter the host name for your license server. Once you've done that, you can confirm what you want to do and then download and install your new license. In the next section, we'll talk about Edge Site, Shadow Taskbar, Role Manager, third-party tools, PowerShell, and the Access Gateway console. Well, let's talk about Edge Site, Shadow Taskbar, Role Manager, third-party tools, PowerShell, and the Access Gateway console. This video gives an introduction or an overview of the XenApp management tools such as Edge Site, Shadow Taskbar, Role Manager, some third-party tools, PowerShell, and the Access Gateway console. Edge Site is a performance and availability management solution for XenApps and desktop and endpoint systems. It monitors applications, devices, sessions, license usage, and the network in real time, allowing users to quickly analyze, resolve, and proactively prevent problems. Shadow Taskbar allows you to shadow multiple ICA sessions or users from a single location, including the server desktop. Keep in mind each session you monitor consumes a license, and it does consume memory on the server. A typical application for this is a hosted application available to support personnel for monitoring and assisting users. You can also shadow sessions from within App Center. Also, be aware of compatibility issues when shadowing published applications and desktops with multi-monitors and screen resolution. You cannot shadow a session with multiple monitors enabled in Windows Server 2008 R2. A workaround is provided in CTX article, the CTX 125693. The Role Manager wizard starts automatically when you run the setup.exe from the XenApp installation media. XenApp uses roles to designate XenApp features and related technologies. Because of the number of components in a XenApp farm, the Role Manager detects each deployment phase for each role and displays the next task required to complete the installation and configuration of that role, including server prerequisites and dependencies. Third-party tools are available, and they can be found by navigating to citrixready.com. Search for XenApp in Products. In the left-hand nav, search for the category System Management, and you'll see a list of several vendors who have been certified to work with XenApp with their products. The Access Gateway console can be accessed from a web browser. Once logged in, you navigate in the left-hand nav down to Access Gateway. Global settings are policies for all traffic. Virtual servers are where you set up the virtual IP addresses for your users to connect into the Access Gateway in order to access the XenApp farm. You can create groups and users, and the policies section allows you to create specific policies for the management of specific users, groups, and traffic. Next, we will take a look at how to deliver applications to your users through what is called publishing XenApp resources, or making applications available to your users. Let's talk about delivering applications. This video provides an introduction to delivering applications through a method called publishing resources. When you publish resources in XenApp, you enable them to be launched virtually to any device, anywhere, anytime. You publish resources in the management tool called Citrix App Center. Hosted applications are installed on servers running XenApp. When users access them, the published applications appear to be running locally on the user devices. Streamed applications are installed in application profiles and stored on a file server. When users access the profile, the applications are virtualized and streamed down to the user device. Data files such as web pages, documents, media files, spreadsheets, URLs can all be published as content. And server desktops can be published so users can access all of the resources available on the server. We will talk more about these methods in the following sections. Next, we will talk more about hosted applications in detail. Let's take a look at the concept of a XenApp hosted application. When you publish an application that is hosted on a XenApp server, it is run on the server, and the application output or user interface is essentially pushed down to the client device over the ICA protocol. One of the easiest ways to remember this paradigm is to think of a hosted application as a very long keyboard, video, and mouse cable running from the server in the data center down to the client device. Hosted applications are installed on the server where the processing takes place and accessed from the server. This is the traditional XenApp application delivery model. For many organizations, this provides the lowest cost of ownership for IT resources because it provides the greatest scalability. This method is useful because it provides a consistent user experience regardless of the user device. You manage applications centrally. User devices do not require extensive resources such as memory and hard drive space. This method supports thin clients and is effective for applications with components that are intertwined with the operating system. Some important considerations are farm servers require sufficient resources to support the applications, and users must be connected to the server or network to run the applications. There is no offline access. Let's take an example and publish a simple application. We know we want to publish the Internet Explorer to all of our users, make it available to them. So we'll go into App Center, Applications, and click on Publish Application. We'll enter a name for the application and a description. This is going to be an application accessed from the server, and we specify the command line and where to launch this application from. And we select the servers we want to run this from. Either of the XenApp servers is fine. And we only want domain authenticated users launching this application, so we'll specify that here. Also, we want to add this to the client's start menu and to their desktop. And when we've published the application, we can launch a browser locally just to test out if it's working. In the next section, we are going to talk more about streamed applications. Let's take a minute to talk about streamed applications. When you publish a streamed application, executables for applications are put in profiles and stored on a file server or web server, also known as the App Hub. When launched, the files required to execute the application are streamed to the user device, and application processing takes place on the user device instead of the XenApp server. When applications are streamed to the user device, the user experience is similar to running applications locally. After applications are cached on the user device, users can continue running the apps even after disconnecting from the network, also referred to as offline access. Before you can publish an application using streaming, it must be profiled or characterized by the target system that it will be run on. For example, a Windows 7 client. You do this by running the Citrix Streaming Profiler application, and then you publish the application using that profile. First, you create a profiler workstation that will mimic your user's environment. The profiler workstation should meet a runtime environment that is as close to the user's environment as possible. Here are some guidelines. Choose a workstation that is similar platform to your user's device. Choose a computer that is freshly imaged so that there are no hidden files or registry settings. Install only the standard programs that are part of the company image, such as an antivirus program. Disable the user account control. If using Microsoft Office applications, be sure to install the .NET framework. And do not install the offline plugin on the profiler workstation. The user device should meet the following requirements. It should have a network connection to the server farm, a supported browser such as IE 6, 7, 8, or 9, and if you're using Office applications, be sure to install the .NET framework. Manually uninstall any previous versions of the streaming clients, and make sure you install the Citrix offline plugin along with the Citrix receiver. Let's look at an example, but make sure you run the profiler on the profiler workstation and not the XenApp server. The application profiler can be found on the installation media. Once it's installed, you launch it from the Start menu. Type in the name of the profile you want to create. Click through most of the defaults, select your target operating system, and then browse to the installer. Here we're going to set up the Firefox browser, so we've selected the Firefox installer. We will launch the installer and install it in that profile. When we're finished, we save that profile off to the App Hub. And then we navigate back to App Center, Applications, Publish Application. However, this time
when we go to select the application type, we will say streamed to client.
In the next section, we will talk about content delivery.
Now let's take a look at content publishing. When you publish content, you make available non-executable information such as multimedia, web pages, documents, text files, pictures, etc. You must specify the uniform resource locator or uniform naming convention path to the file you want to publish. When you enable server-to-client content redirection, embedded URLs are intercepted on the XenApp server and sent to the client device, and the web browser or multimedia players on the client device open these URLs. This feature frees servers from processing these types of requests by redirecting application launching for supported URLs from the server to the local device. The browser locally installed on the client device is used to navigate the URL. Users cannot disable this feature. Accessing published content with local client desktops does not use XenApp resources or licenses because local viewer applications do not use XenApp sessions to display the published content. When you publish content, you need to specify the location using address formats such as the following. For HTML websites, documents, FTP server directories, documents on FTP servers, or file share paths or directory paths. To make this happen, you need to configure a policy in App Center. Navigate to the category ICA, file redirection, and set the host to client redirection enabled. Let's take a look at an example. We navigate to Applications in App Center and publish an application. And let's publish the Citrix website. We select Content and enter the website address. Configure the users that we want to access this content. And when we are done, we can log into XenApp and test out the launching of this content. And you see here when we launch the content, it arrives in the local browser, not through the Citrix receiver.
Next, we're going to talk about publishing the server desktop.
Now let's take a look at how we publish a server desktop. When you publish the server desktop in XenApp, it publishes the entire Windows desktop of a server in the farm. When the plugin connects to the server, the user sees a desktop interface from which any application installed on that server can be started. After selecting this application type, you must specify the server that you want to publish from. To publish a desktop, you must be running XenApp. If you are running the Citrix App Center on a computer that is not running XenApp, you cannot publish that local desktop. Publishing the desktop in this manner is also known as a hosted desktop, which is not to be confused with the virtual desktop that is delivered by another Citrix product called XenDesktop. Keep in mind if you publish a server desktop to lock down sensitive areas. Let's take a look at an example. From App Center, we'll go to Applications, Publish Application, and specify that we'll launch the desktop. Under Application Type, we select Server Desktop, the server that we want to publish the desktop from, configure the users that we want to access this desktop. And when it's finished, we can launch a browser, log into the web interface, and test out launching the desktop.
In the next section, we talk about application streaming. Let's take some time to focus a little more on application streaming. Application streaming simplifies application delivery to users by virtualizing applications on client machines. After you create the profiles for applications using the streaming profiler, you make them available for streaming to users by publishing the applications. The Publish Application Wizard in the Citrix App Center guides you through the process of selecting the streaming options. You configure the application streaming delivery method as you publish the application, and you choose delivery options based on the users who will access the applications in their environments. The profiled applications must be stored on a file share or web server that is accessible from your XenApp server, so you can publish the application, and it must be accessible by your users so they can launch the application. Application streaming might seem daunting at first, but it can be reduced to some simple steps. Locate a test profile workstation that most closely mimics the type of system your end users will be using. Install the Citrix Profiler application and run it. The Citrix Profiler application can be found on the XenApp installation media. While running the profiler, install the application you want to stream, save the profile on the server, and then publish the applications to the users in App Center. There are a few reasons why you would want to stream an application. Once configured and delivered, applications are available to the user while disconnected from the network. On-demand application delivery is a powerful concept for disaster recovery situations because the application and data are not lost if the profiles can be easily backed up and servers and desktops can be easily replaced. It provides the ability to install an application once on a profiler workstation and have it replicated to file servers within the existing enterprise. There is no need to profile applications again. Updates are as simple as updating an application on a desktop using the update program supplied by the manufacturer. The update is performed once on the profiler workstation and delivered to client devices in a manner similar to that used in the initial delivery. All streamed applications run within an isolated environment that keeps the applications from interfering with others running on the same device. The isolated environment is specific for the application and user session, regardless of whether the user streams to the local client or virtualizes the streamed applications from a server. The specific data files of the application, such as INI files and registry keys, are all isolated and maintained centrally for the streamed application. Application files can be cached on the client device to allow faster access the next time the application is launched. Nearly any modern Windows platform can host a streamed application. Specifically, supported operating systems include Windows XP, Windows Server 2003 and 8, Windows Vista, and Windows 7. You can configure XenApp to stream software to client devices, otherwise virtualized from a XenApp server. If launching a streamed application fails on the client device, XenApp seamlessly streams the application to the server and virtualizes the application on the client device from XenApp. This is known as dual mode streaming. When publishing applications in a server farm, you can choose to virtualize the applications from XenApp, which can simplify application delivery. Instead of installing applications on your farm servers, you stream them to XenApp from a central file share in your App Hub. Applications that can be accessed through the server can appear next to other applications that the user is accustomed to, either within the web interface, Citrix plugins, or on the desktop. In the next section, we look at system requirements for application streaming. Let's take a minute to look at some of the requirements around application streaming. Version 6.5 of the Citrix Offline plugin and Streaming Profiler are supported on the following target operating systems: Windows XP Home and Professional Editions, Windows Server 2008 32 and 64-bit editions, Windows Server 2003 R2, Windows Server 2008 R2, and with Service Pack 1, Windows Vista, 32 and 64-bit, and of course Windows 7, 32 and 64-bit. Version 6.5 of the Citrix Offline Plugin and Streaming Profiler are supported on the following Citrix products: Citrix XenApp 5, 6, and 6.5, XenDesktop 4, 5, and 5.5, Citrix XenServer, all supported versions, Citrix Receiver for Windows 1.x, 2.x, and 3.x, and for the Citrix Online plugin, Citrix recommends 13.0, which is installed with the Citrix Receiver 3.0, but past versions 11.2 and 12x are also supported. The Profiler workstation and end-user devices must meet the following requirements. Microsoft XML 2.0 must be installed. A standard PC architecture with an 8386 processor or greater is required for the operating system. Administrator rights must be there for the person installing the software. In addition, the Profiler workstation must provide a runtime environment that is as close to the user's environment as possible. So use these guidelines. Choose a workstation that is similar in a platform to your user's devices. Use a computer that is freshly re-imaged so that there are no hidden files or registry settings for applications that you intend to profile. Install only the standard programs that are part of the company image, such as an antivirus program. Disable the user account control, and to stream Microsoft Office 2007 or 2010 programs, or to stream profiles enabled for inter-isolation communication, install the .NET framework. Do not install the offline plugin on the Profiler workstation, but you can install the Citrix Receiver. And don't install applications on the D drive, use the C drive, because some computers don't have D drives. The user devices must meet the following requirements: a network connection to the server farm, such as a network interface card, a supported browser, such as Microsoft Internet Explorer, and to stream Microsoft Office 2007 or 2010 programs, be sure to install the .NET framework, manually uninstall any previous versions of the streaming client and program neighborhood agents on the user devices, and to ensure availability of the features and functionality of XenApp or Windows Server 2008 R2 to your users, install the offline plugin and the most recent version of the Citrix Receiver, which includes the online plugin. In the next section, we'll take a look at the components of application streaming. Let's take a moment to look at the components that make up application streaming. The components related to a server farm that make applications available for streaming can be separated into 4 categories. Each of these functional categories consists of software running on one or more workstations or servers. Before you install the components for application streaming, refer to the system requirements for application streaming. The components that support virtualization on the user device, such as shown in the diagram, include the XenApp server, Citrix licensing, streaming profiler workstation, file servers, web interface, and Citrix clients. Licensing consists of the Citrix license server and license management console. The Citrix streaming profiler creates and maintains streaming application profiles. The streaming profiler is an independent application that enables you to profile Windows applications, web applications, browser plugins, files, folders, and registry settings that can be streamed to user devices and servers. You use the profiler to create one or more targets within an application profile that can match all the platforms of your users. This strategy creates a single profile that can accommodate a variety of user platforms. The profiler can also update applications in the profile and provide other resources that your users need. The XenApp server farm consists of farm servers, the IMA database, the web interface, and App Center, which is used to configure and manage the server, delivery, and publish applications for streaming. And of course, you will need the Citrix clients on the user device. In the next section, we'll look at Citrix plugins and Receiver. Let's take a minute to look at the clients used for streaming. As a quick review, let's talk about the different Citrix clients and where they are needed. Citrix Receiver is a universal software client that provides secure, high-performance delivery of applications and virtual desktops. The Citrix Offline plugin streams applications from profiles stored on the server. The Citrix Online plugin you use to integrate published resources directly with users' desktops. The Citrix Web plugin you use to access published resources from an internet browser. The offline, online, and web plugins can be installed with the Citrix Receiver and can be found in the Citrix Receiver Preferences menu. For streaming, you will need two Citrix plugins. The offline plugin supports streaming applications to the user's desktop. To provide offline access to applications and dual mode streaming, you'll need both the offline plugin and the Citrix Receiver Enterprise, which includes the online plugin on user devices. When a user runs a published application enumerated by Citrix Receiver or through a web interface site, the offline plugin finds the correct target in the profile in the App Hub, sets up the isolated environment on the user device, and then streams the application from the profile location to the safety of the isolated environment set up on the user's device. To support streaming applications to the server, install the Citrix Receiver on user devices. These applications must be published as Stream to Server. When users run an application, it streams to the server and launches using an ICA connection on the user device. If you're not sure which Citrix plugins you're running, you can find those in the Citrix Receiver Preferences menu. Check plugin status, and here you can see all of the Citrix plugins that are installed on your system. In the next section, we'll take a look at policies and printing. Let's take a minute to look at policies. To control user access or session environments, you configure policies in XenApp. Policies are the most efficient way to control connections, security, and bandwidth settings in XenApp. You can create policies for specific groups of users, devices, or connection types. Each policy can contain multiple settings. You can work with policies through the Group Policy Management Console in Windows or the App Center in XenApp. The console or tool that you use to do this depends on whether or not your network environment includes Microsoft Active Directory and whether or not you have the appropriate permissions to manage group policy objects. If your network environment includes Active Directory and you have the appropriate permissions to manage group policy, use the Group Policy Management Editor. You use this to create policies for the XenApp servers in your environment. The settings you configure affect the GPOs you specify through the Group Policy Management Console. If your environment includes a different directory service, or you are a Citrix administrator without permission to manage group policy, use the App Center to create policies for your farm. The settings you configure here are stored in a farm GPO in the data store. Group policy settings are processed in the following order: local GPO, XenApp Farm GPO stored in the farm data store, site-level GPOs, domain-level GPOs, and organizational units. However, in the event of a conflict, policy settings that are processed last can overwrite those that are processed earlier. This means that policy settings take effect in the following order: organizational units, domain-level GPOs, site-level GPOs, XenApp Farm GPOs, and local GPOs. For example, a Citrix administrator creates a policy, Policy A, through the App Center that enables client file redirection for sales employees. Meanwhile, another administrator creates a policy, Policy B, through the Group Policy Management Editor that disables this function. When the sales employees log onto the farm, Policy B is applied and Policy A is ignored. This happens because Policy B was processed at the domain level and Policy A was processed at the XenApp Farm GPO level. Citrix policies are supported for use in Active Directory environments running at the Windows 2000 domain functional level at a minimum. To ensure Citrix policy settings are included in reports when resultant set of policy is calculated, at least one domain controller running Windows Server must be present in the forest. The process for configuring policies is as follows. Create the policy, configure the settings, apply the policy to filters, prioritize the policy, and verify the policy running the Citrix Group Policy Modeling Wizard. In the next section, we look at best practices for policies. Let's take a minute to talk about policies and best practices. In Active Directory, policy settings are collected into two main categories, computer configuration and user configuration. Computer configuration settings pertain to servers, regardless of who logs on. User configuration settings pertain to users accessing the server, regardless of where they log on. XenApp policies and settings are collected into similar categories, computer and user. Computer policy settings pertain to XenApp servers and are applied when the server is rebooted. User policy settings pertain to user sessions and are applied for the duration of the session. In the App Center console, you can access policies and settings by clicking on the Policies node from the console tree and then selecting either the Computer or User tabs in the middle pane. In the Group Policy Management Editor, you can also access policies and settings by clicking on the Computer Configuration or User Configuration. The Computer and User tabs each display a list of the policies that have been created. Beneath this list, the following tabs should be displayed. Summary displays the settings and filters currently configured for the selected policy. Settings displays by category the available and configured settings for the policy. And Filters displays the available and configured filters for the selected policy. From these consoles, you can search the policies you create and their settings and filters. All searches find items by name as you type. You can find searches from the following places. Use the Search tool in the Settings tab or use the Search tool on the Filters tab. The following is a list of best practices when creating policies. Limit the number of policies, create one policy, and apply filters to it. Disable unused policies. Unused policies waste processing resources. Assign policies to groups. If we assign policies to groups rather than each user, management is easy and can reduce processing time. And avoid using the remote desktop session host configuration settings as they could overlap with the XenApp policies. When creating policies, follow these guidelines. Create the policy and give it a name. We need to choose if we are going to create a user configuration or computer configuration policy, and then set that policy. Using filters, we can choose to apply the policy to a specific group of users or computers. And finally, we need to assign a priority to the policy so that it will take precedence over other policies. In the next section, we talk about implementing policies. Let's take a look at some examples of implementing policies. To launch the App Center, navigate to Management Consoles and click on App Center. The XenApp App Center will come to the display. And you can find policies under the farm name in the Policies folder. Here you can view the policies per computer or user. And you can select the tabs Summary, Settings, and Filters. Let's implement a common policy. The client drive redirection setting controls whether or not users are allowed to access the drives on their devices. To configure this, we'll click on the User tab. We click on New and create a new policy. Then we search for the file redirection policies, enable them, assign it to a worker group, and then finally create the policy. As mentioned earlier, you can also create policies using the Group Policy Management Editor. And you do this by going to the Start menu and typing in gpedit.msc, and it will launch the Group Policy Management Editor. And here you can see the computer configuration policies and user configuration policies, similar to the way they would appear in App Center. A complete listing of all the policy settings can be found in the Citrix eDocs. In the next section, we take a look at printing. In this section, we take a look at an introduction to printing. In a XenApp environment, all printing is initiated by the user on the XenApp server. However, print jobs are not always sent directly from the server to the printing device. Instead, print jobs can be redirected through the client device. Because there is no persistent workspace for users in XenApp, in other words, when a session ends, the user's workspace is deleted, all settings need to be rebuilt at the beginning of each session. As a result, each time a user starts a new session, XenApp must re-provision the printers available in that session. Having said that, it is possible to provide persistence to user printing preferences in XenApp. When a user clicks Print, XenApp determines what printers to provide to the user. This is known as printer provisioning. XenApp restores the user's printing preferences and determines which printer is the default for the session. An important concept in XenApp is the printing pathway. The term printing pathway encompasses both the path by which print jobs are routed and the location where print jobs are spooled. Both aspects of this concept are important. Routing affects network traffic and spooling affects utilization of local resources on the device that processes the job. In XenApp, print jobs can take two different pathways, through the network or through the client. The term network printing pathway refers to print jobs that are routed from the farm server hosting the user's session to a print server and spooled remotely. The term server local printer refers to a configuration that uses the network printing pathway where printing devices are attached locally to a XenApp farm server. The term client printing pathway refers to print jobs that are routed over the ICA protocol through the client device to the printer, either a printer connected directly to the client device or connected through a print server, and spooled on the Citrix Online plugin. When using the client printing pathway, a virtual printer is constructed in the session that redirects to the printer object on the client device. While client printers are often printers physically attached to client devices, they can also be printers on the network. In this case, print jobs are routed through the client device to the print server. The process is the same as for printing to a local printing device through the client. However, instead of sending the job to the client device, the job is sent to the network print server. For a computer to process a print command, it needs both the required printer object and a printer driver. Because sessions are hosted in a virtual workspace instead of locally on a hard drive, printers and their drivers are not stored on the local computer. Instead, they are restored at logon or reconnect. The process by which XenApp makes printers available in a session is known as provisioning. You can control provisioning for printers, and the way you configure it affects what printers users see in the sessions and the speed of the printers. There are two types of printer provisioning, static and dynamic. In static provisioning, server local printers are provisioned only once when you connect them to the farm server. After that, they are always created in sessions with the same properties and do not vary according to policies. Dynamic printers are available in a session and are determined as the session is built. As a result, they can change according to changes to policies, changes in user location, and changes to the network. When printers are provisioned dynamically, the printers that appear in a session are not predetermined and stored. Rather, the printers are assembled based on policies when the session is built. When the client printer redirection policy is set to enabled, auto-creation automatically creates all printers on a user device. In the next section, we learn how to assign printers and work with printer drivers. Let's walk through an example of how to assign a printer to a group of users using policies. We'll open App Center, navigate to Policies, click the User tab, and under Settings we'll find the Printing Policies. Here we can find Session Printers. We'll click on Add, and then we'll add a network printer. Once we click OK, that printer is now bound to all of the users that have that policy applied to them. To specify the default printer, we select the default printer policy, and then select the printer we want the users to have as their default whenever they log into XenApp. To let users connecting to the farm print to a printer that is locally attached to the farm server, connect the printer to the farm and share it using this method. Navigate to the control panel, Hardware, Devices, and Printers, and right-click on the printer you want to share. Select Printer Properties. In the Sharing tab, select Share this printer and render print jobs on client computers. Managing printer drivers is critical for successful printing. When XenApp auto-creates printers, it determines if the corresponding drivers are missing. By default, XenApp installs any missing printer drivers from the Windows native printer driver set. We can either prevent printer drivers from being installed automatically, or if we want to have them installed, we can control what drivers are installed on XenApp servers. To prevent drivers from being installed automatically, we can configure the Citrix policy setting for automatic installation of in-box printer drivers. The enabled option allows Windows native drivers to be automatically installed on the XenApp server. Disabling this setting prevents the automatic installation of printer drivers. The Citrix Universal Printer is a generic printer created at the beginning of sessions that can be used with almost any printer. Using a single print driver simplifies the deployment of a XenApp farm. By default, universal printers are not auto-created. We can enable this by using a policy. We can configure the universal printing policy by choosing one of the following. Use only printer model specific drivers, use universal printing only, use universal printing only if requested driver is unavailable, and use the printer model specific drivers only if universal printing is unavailable. The Citrix Universal Print Server now supports network printing. The Universal Print Server eliminates the need to install numerous network printer drivers on XenApp and enables more efficient network utilization. In the next section, we look at multimedia content and HDX. Let's take a couple of minutes to talk about HDX. Citrix HDX includes a broad set of technologies designed to provide a high-definition user experience. HDX builds on existing technologies in Citrix products, extending them with new innovations for today's media-rich user environments. HDX technology is a set of capabilities that delivers a high-definition virtualization experience to end users for any application, device, or network. These user experience enhancements balance performance and low bandwidth. Anything else becomes impractical to use and scale. HDX Media Stream works together with HDX Adaptive Orchestration to deliver audio and video content. Whenever possible, HDX Media Stream leverages the processing power of the endpoint device to render the multimedia content. On the data center side, the compressed multimedia information is sent directly to the endpoint in its native format. HDX Real-Time is supported by bidirectional audio capabilities. This enables users to connect audio peripherals such as microphones and dictation hardware at the endpoint device, and they interact with virtual desktops and virtual applications hosted in the data center. HDX Broadcast leverages the ICA Remote Display Protocol to optimize the reliability and performance of hosted virtual desktops and applications over any network, enabling a high-definition user experience when accessed on the corporate network or from outside the corporate network for remote desktop access. HDX Smart Access allows users to securely access desktops and applications using any device in any location, including home computers, kiosks, and mobile devices. In a virtual desktop or virtual application environment, HDX Plug and Play enables simple connectivity for USB, multi-monitor, printers, and other peripheral devices as well as local machine resources. HDX Rich Graphics enables you to optimize the performance of graphics-intensive 2D and 3D media-rich applications. HDX WAN optimizes performance and network utilization across a WAN by compressing, caching, and prioritizing traffic. When it comes to user experience, there are several factors to balance: performance, security, endpoint flexibility, network conditions, and infrastructure cost. HDX Adaptive Orchestration is designed to help you dynamically balance these factors based on device, network, user, or application to make the best use of existing infrastructure and computing power. To find out more about HDX, navigate to http://hdx.citrix.com. In the next section, we talk about HDX 3D. Let's take a minute to look at HDX 3D. Citrix provides HDX 3D technologies to improve image display and reduce CPU load of graphics-intensive applications. In environments with intensive use of graphics applications like image editing or manipulation applications, large images are transferred between XenApp servers and client machines. XenApp includes policies to manage image compression and improve image display. Those policies can be found under lossy compression and progressive compression. Lossy compression can be adjusted to reduce the bandwidth consumption and improve responsiveness for the user, such as in the use case of connecting over a WAN. Progressive compression is useful when the quality of images is absolutely paramount, for example, in a doctor's office. Depending on where your user is located, they might be close to the XenApp server, or they might be in a remote office across a WAN. In either case, you might want to consider changing your compression settings to suit the needs of either. Image compression is enabled by default, but you can configure the lossy compression level with one of the following options. It can be found in the user settings under Visual Display, Still Images, Lossy Compression Level. Here you can change the level of compression. High compression provides low image quality. Medium compression provides good image quality. Low compression provides high image quality. And if you select none, no compression is applied, and quality is almost the same as the original file. Another important setting is the lossy compression threshold value. This represents the maximum bandwidth in kilobits per second for a connection in which lossy compression is applied. Citrix Progressive Display helps improve the performance of an application, showing an initial compressed version of an image file, and if the image file doesn't change, the image is processed in the background and replaced by a high-quality image. In the next section, we look at HDX 3D graphics and audio. Let's take a minute to look at HDX 3D graphics and audio. HDX broadcast display settings are used to improve the response when graphics are sent to the client machine. We can configure HDX broadcast display settings using the ICA graphics policies. We can use the display memory limit setting to change the maximum video buffer size for the session. If the memory limit is reached, the display degrades according to the display mode degrade preference setting. The display mode degrade preference setting specifies color depth or resolution as it degrades first when the session display memory limits are reached. We can use the image caching setting to enable or disable caching of images in sessions. This setting, when enabled, makes scrolling smoother. The maximum allowed color depth setting specifies the maximum color depth allowed for a session. By default, it's set to 32 bits per pixel. The Notify User when display mode is degraded setting shows a message to the user when the color depth or resolution is degraded. The queuing and tossing setting is enabled by default. This setting discards queued images that are replaced by another image. This improves the response time when graphics are sent to the client machine. With HDX Audio, we can specify the sound quality for our users. Select Low for low bandwidth connections. Sounds sent to the client here are compressed at up to 16 kbps. This results in a significant decrease in the quality of the sound, but allows reasonable performance for low bandwidth connections. Select Medium for delivering voice over IP applications. Audio sent to the client here is compressed at up to 64 kbps. This results in a moderate decrease in the quality of the audio played, but provides low latency and consumes very low bandwidth. Select High when delivering multimedia applications. This setting provides high-fidelity stereo audio, but consumes more bandwidth than the medium setting. Use this setting when network bandwidth is plentiful and sound quality is important. Also, you can enable audio to be played directly from the client machine. In the next section, we look at Media Stream Multimedia. In this section, we look at Media Stream Multimedia. We can improve the multimedia experience of the users by enabling the HDX Media Stream Multimedia Acceleration feature. This feature optimizes multimedia playback running in Internet Explorer, Windows Media Player, and the Real One player, and for significant performance improvements in CPU utilization and network bandwidth. We can reduce the CPU use of XenApp servers by moving the multimedia content processing to the client machine. The multimedia content is compressed and delivered to client machines, reducing bandwidth consumption. HDX Media Stream Multimedia Acceleration optimizes playback of multimedia files that are encoded with codecs that are compatible with Microsoft's DirectShow and DirectX. The codec, compatible with the encoding format of the multimedia file, must be present on the client machine. The following are the client machine's requirements to use HDX Media Stream Multimedia Acceleration. The codec required to decompress and play the multimedia file must be installed on the client machine. The Citrix Online plugin must be installed on the client machine, and the client must have enough memory and CPU available to process the multimedia playback. The following Media Stream Multimedia policy settings can be found in the App Center Policy Manager. Under the Computer tab, ICA, then select Multimedia. Let's take a look at an example. By default, Windows Server 2008 R2 does not install the Windows Media Player. If you want to play multimedia content on the XenApp farm, you will need to install the Desktop Experience feature. The multimedia conferencing setting allows support for video conferencing applications. By default, video conferencing support is enabled. The Windows Media Redirection setting enables HDX Media Stream Multimedia Acceleration. This setting controls and optimizes the way XenApp servers deliver streaming audio and video to clients. The Windows Media Redirection Buffer Size setting specifies the buffer size to use for multimedia acceleration. By default, it's set to 5 seconds, but we can increase this setting in high latency networks. The buffer size use setting enables using the buffer size specified in the HDX Media Stream Multimedia Acceleration default buffer size setting. In the next section, we look at multimedia flash. In this section, we take a look at Media Stream for Flash. We can enable HDX Media Stream for Flash to move or redirect the processing of Adobe Flash content to the client machine, rather than using the network resources, and this reduces the XenApp server and network load, and also improves the amount of sessions we can have per server. HDX produces a high-definition experience when users access Flash content including animation, videos, and applications. Playing Flash content on a XenApp server is usually slow because Adobe Flash renders the content on the server, by default in high-quality mode. This causes high bandwidth usage. In order to run Flash on the client machine, you will need to install the online plugin or Citrix receiver for that client. It should also have the latest Adobe Flash Player installed and make sure the network connection is fast, and that there is enough memory and CPU to process the content on the client. The following media stream Flash policy settings can be found in the App Center Policy Manager, under the User tab, ICA, Adobe Flash Delivery. Let's take a look at the examples. When Flash acceleration is enabled, it reduces network and server load by rendering Flash content on the client machine. When it's disabled, Flash content from the websites, regardless of the URL, is rendered on the XenApp server. This is the default setting. Enabling Flash event logging is important for troubleshooting Flash content rendering. We enable that here. The Flash latency threshold setting specifies a threshold between 0 and 5,000 milliseconds to determine where Adobe Flash content is rendered. By default, the threshold is 30 milliseconds, and during startup, HDX Media Stream for Flash analyzes the content latency between the server and the client. If the latency is under this value, HDX Media Stream for Flash is used to render Flash content on the client machine. The Flash server-side content fetching URL list is a whitelist for server-rendered Flash content media. The Flash URL compatibility list is a whitelist for client-rendered Flash media. Let's take a look at a quick tip. I launch an Internet Explorer from the XenApp server and navigate to YouTube. I've navigated to a high-definition video, which is running in either 720p or 1020p. If I play that video, it's very smooth. If I grab the frame and move it, you can see that the video follows the Internet Explorer frame. This tells me that video is rendered on the server. If I enable Flash acceleration on the client and go to the same video on YouTube, and then drag the Internet Explorer, you see that the video pops out of or drags behind significantly the Internet Explorer frame. This tells me that media is being rendered on the client. In the next section, we look at managing, monitoring, viewing, customizing, and optimizing. In this section, we take a look at monitoring XenApp. Monitoring XenApp sessions is very simple. We go to the Start menu and launch the Citrix App Center, and we navigate to the server farm and we select one of the servers, and in here we can find everything we need to monitor XenApp. We have the username that initiated the session, the session ID, the application that was launched, the session type, either ICA or RDP, the machine or client name, the logon time, idle time, and the XenApp server on which the application is running. In the lower portion of the results pane, we can see information such as client cache, session information, client modules, and processes tab. We can select a session, and depending on that session, some tasks become available, such as reset, log off, disconnect, or send a message to that user. If we launch the Server Manager on the XenApp server, we can add some performance monitoring metrics. In here we can select metrics for the ICA session. In the next section, we take a look at managing XenApp. In this section, we look at managing XenApp. We can use App Center to manage XenApp sessions. In App Center, we can view users and sessions. And from in here, we can disconnect, reset, log off, or send messages to users on XenApp. We notice in the Sessions tab that there are two special sessions, ICA TCP and RDP TCP, and these are in the listening state. If we reset any of these listening sessions, the server resets all sessions that use that protocol associated with the listener. Sometimes a process inside of a session is hung. We'll navigate to Users, select Processes, and then click on that process, and we can terminate it from this console here. Sending a message to user sessions is common practice to notify users of XenApp server reboots and to alert users about issues with published applications, or for requesting a shadowed session from a user. In this example here, we are going to send a message to a XenApp user. In the next section, we take a look at viewing XenApp sessions. In this section, we'll take a look at viewing XenApp sessions. We can view user sessions running on a remote machine by using shadowing. When shadowing is enabled, we can monitor the session activity. If configured, we can also use the keyboard and mouse to control the user's keyboard and mouse remotely in the shadowed session. Shadowing is a powerful tool to assist and monitor users. From the Shadow taskbar, we can select from a list of available users and send out a request to shadow those users. To enable shadowing or allow other users to shadow each other, we need to enable that in the Policy Manager. When we enable session reliability, any minor disconnection from the network keeps the session active, allowing users to remain connected, but with the screen frozen and cursor changed to the hourglass. This continues to keyboard input until the network connectivity resumes or the timeout is reached. Session reliability can be configured through the policy settings. In the next section, we'll look at customizing. In this section, we'll take a look at customizing XenApp. XenApp provides different ways to control what users experience in their session environments. We can customize user environments, including suppressing or hiding login progress bars, allowing or restricting users from accessing their local devices, ports, multimedia content, or applications. We can also customize the user's experience by choosing whether we want published apps and desktops to appear in a window within a remote desktop window or seamlessly. In seamless window mode, published applications and desktops appear in separate resizable windows, which makes the application seem to be installed locally. We control the appearance of user logons using the Group Policy Management Editor. We can provide access to local devices and ports using policies. Client device mapping provides access to local drives and ports, allows us to cut and paste data between the client machine and the session, and allows multimedia playback inside the session. Drive mapping can be found under the File Redirection policy, and the redirection of COM ports and audio can be found under the Port Redirection policy. We can also use policies to limit concurrent connections and limit the number of sessions per server. In the next section, we'll look at optimizing XenApp. In this section, we look at optimizing XenApp. We can use the Speed Screen Latency Reduction Manager to configure speed screen latency reduction settings for a XenApp server, for single or multiple instances of an application, as well as for individual input fields within an application. XenApp includes various features to improve user experience by improving keyboard and mouse responsiveness. The speed screen latency reduction is a collective term used to describe features such as local text echo and mouse click feedback that help enhance user experience on a slow network. On high latency connections, users often click the mouse multiple times because there's no visual feedback that a mouse click resulted in an action. Mouse click feedback, which is enabled by default, changes the appearance of the pointer from idle to busy after the user clicks a link, indicating that the system is processing the user's request. On high latency connections, users frequently experience significant delays between typing text and when it is displayed or echoed on the screen. When a user types text, the keystrokes are sent to the XenApp server, which renders the fonts and returns the updated screen to the client machine. By default, local text echo is disabled, but we can enable it. We can enable special folder redirection to simplify the way that users save files to their special folders locally. Special folders are Windows folders such as Documents, Computer, and Desktop. When special folder redirection is disabled, the documents and desktop icons that appear in a session point to the user's documents and desktop folders on the XenApp server. We enable special folder redirection by using the Web Interface Manager. In the next section, we look at scripting and virtualization. Let's take a couple of minutes to talk about scripting. Before XenApp 6.0, MFCOM was used by developers and administrators to create utilities and scripts to automate administration tasks on Citrix XenApp farms. With XenApp 6.0 and 6.5, all scripting is done in PowerShell. MFCOM is no longer supported. If you have scripts written in MFCOM, there is a way to convert them to PowerShell. By referencing CTX article CTX 125089. PowerShell scripts for XenApp are powerful and can be used for many purposes such as installing and managing XenApp farms, publishing applications, adding users to applications, creating policies, adding and removing XenApp servers to farms, upgrading from XenApp 6 to 6.5, creating desktop experiences for users, using pre-launch scripts before an application launches and post-exit scripts when applications are exited. And the PowerShell scripts can be used from within .NET applications. PowerShell scripts use what are called commandlets. Citrix provides commandlets for XenApp, so you can use PowerShell scripts along with the commandlets to manage XenApp farms. Let's take a look at some examples. If you're not familiar with PowerShell, you can navigate to the Script Center on Microsoft.com. Here you can find a Getting Started link, and you can download the PowerShell Quick Reference Guide for Windows. The PowerShell scripts for XenApp are found on the Citrix community site under community.citrix.com/display/xa/download+SDKs. Here you can find several SDKs for XenApp, but we're interested in the last two files, XenApp 6.5 PowerShell SDK and the XenApp commands for PowerShell. In the next section, we'll take a closer look at the XenApp SDK and scripting. In this section, we look at the XenApp SDK and scripting in more detail. Once we've downloaded the PowerShell SDK for XenApp and the PowerShell XenApp commands, we unzip and install them. Here we're installing the XenApp SDK. And here we're installing the Citrix XenApp commands. Once successfully installed, we can launch the PowerShell Citrix command console from the Start menu. If we issue the command get command, it will give us a list of all the commandlets that are available. You can also get help by typing in get-help and then the name of the commandlet. Issuing the command get XenServer will return a list of the XenApp servers. And issuing the command get XenApplication will return a list of the applications that are published on XenApp. We can even use pipes to make the display or output even more meaningful. We can export the data to a .csv file or even to an HTML file. If we need help with the XenApp commandlet, we can type get help get-xa asterisk, and it will return all of the XenApp commandlets. In the next section, we take a look at XenApp in a virtualized environment. Let's take a minute to talk about virtualization and how it applies to XenApp. Citrix has been virtualizing applications on XenApp for years, so the concept is nothing new. In fact, virtualization of applications is a key component of the Citrix virtualization strategy. Traditionally, each XenApp server had to be installed on its own Microsoft Windows server, including the hardware to support it. Now, when using hypervisors, that hardware server can be virtualized so that many instances of the XenApp server can be installed on one piece of hardware. There are several benefits to virtualizing XenApp, including faster server provisioning, server consolidation, improved server utilization, lower cost, improved disaster recovery, zero downtime for maintenance, dynamic workload management, and a lower cost of testing and proof of concepts. XenApp can be installed on servers that have been virtualized on any of the leading hypervisors, such as Citrix's own XenServer, Microsoft's Hyper-V, and VMware's ESX. Installing XenApp on a Windows server or virtual machine is the same as installing it on physical hardware, so installation should be straightforward. In fact, this entire demonstration, all these chapters that we've been going through and looking at examples, have been done using XenApp installed on a virtual machine running on top of Citrix XenServer, as you can see from looking at the Xen Center console here. Installing XenApp on a virtual machine is easy and straightforward. First, you create a new virtual machine running Windows Server, and then you install XenApp on top of that. When Windows is finished installing, you can mount the XenApp DVD and the DVD drive in Xen Center, and then go ahead and install XenApp. In the next section, we take a look at XenApp in the cloud. In this section, we take a look at XenApp in the cloud. Since we know that XenApp is supported on XenServer, Hyper-V, and VMware ESX, it only makes sense that we should be able to run it in the cloud. XenApp is supported in the cloud. For example, you can build a XenApp server in Amazon Web Services Cloud. You can build one in Rackspace, or you could even build one in SoftLayer, just to name a couple of providers where XenApp is supported. First thing I need to do is navigate to the EC2 and select AMIs in the left-hand navigation. And here I want to look at images created by Amazon, and I want to look for 2008 R2 images. So I pick the basic install here. Amazon has created a Windows Server template already for me, so I select this one. And then I click on Launch. I'll select a medium-sized server. And I can launch it in EC2. I'll go ahead and finalize the launch. Once the server has been created in Amazon, I can get Windows password using the key that I created. And since RDP is already enabled, I can connect directly to that virtual machine in the Amazon cloud. And once connected, the first thing I want to do is run the EC2 configuration service. And I want to deselect the set computer name and deselect the enable password to change the password. And then I can set the administrator password to something that's a little easier for me to remember. Now I need to download XenApp 6.5 from the Citrix website. And then I need to download this tool called Virtual Clone Drive, which allows me to mount images on a virtual machine as if they were mounted in a DVD drive local to that machine. Once that's installed, I can mount the XenApp ISO image, go to my computer and click on the DVD drive, and now I can install XenApp on the virtual machine in the Amazon cloud. There's one other piece of information you're going to need, so you want to navigate to blogs.citrix.com and to my blogs series there. There's a blog called XenApp 6.5 in the cloud, and you want to select that. It has all the instructions you need for building XenApp in Amazon EC2. There is one executable you'll need, and it's set alt address service. And that is to allow connections to come in and out of the Amazon NATing device. In the next section, we take a look at troubleshooting XenApp. In this section, we'll look at troubleshooting XenApp. Troubleshooting XenApp couldn't be easier. All you need to do is navigate to one of the many websites that are available. You can start with blogs.citrix.com and search for solutions there. You do want to check out CTX article 126294, as this lists a lot of different tools that are useful for troubleshooting XenApp, such as the Citrix Quick Launch and the CDF control, to name a couple. You can always just navigate to support.citrix.com and search in the knowledge base. And you can also go to docs.citrix.com and look for product documentation. And you can filter results if you need to find something specific. So if we wanted to look up HDX for XenApp 6.5, you could search on that and it brings back a list of results that we can browse through to look for answers to our problem. Another thing worth mentioning is you can navigate to the Citrix support forums, where you can find people asking questions and those questions being answered by Citrix technical support individuals. This concludes the XenApp video training series. Thank you for attending.